Okay, let's look at the concept of pH in reference to this idea of hydrogen ions and the concentration of hydrogen ions and acidic things and basic things. And we're going to start out by just making a scale. So go ahead and draw yourself a scale, like kind of a polarized scale. In fact, we're probably going to want a center line in the middle to distinguish between my ends. And I want you to label one end acidic and one end basic. And I'll tell you right now, it doesn't matter which end you label. I'm going to randomly choose this side to label as acidic. And I'm going to label this side as basic. Having pen issues. This ain't cool, man. This ain't cool. Now, you use your brain. And you tell me which one is going to have a higher concentration of hydrogen ions. Hopefully you remember, dude, that's the definition of acids. Acids have a high concentration of hydrogen ions. The brackets around a substance indicate concentration. Basic substances, we know, have a low concentration of hydrogen ions. You're good? Okay. I'm going to tell you, okay, here's what I'm going to do. I'm going to actually give you a number. I'm going to give you a molarity, a concentration of hydrogen ions, and I'm going to give you two to start off with, and I'll write them here, and then you're going to put them on your scale. Are you ready? I have 1 times 10 to the negative 1 hydrogen ions per liter. Moles of hydrogen ions per liter. And then the other number that I have is 1 times 10 to the negative 14 moles of hydrogen ions per liter. Okay, before you do anything, I need to know which number is bigger. Which number indicates more hydrogen ions in that solution? Which one is a more concentrated solution with hydrogen ions? And hopefully you know, dogs, the negative exponent. Do you see it? The negative exponent means that we're actually going to take this number is equal to 1, moving our decimal point one number to the left because it's a negative number. If we had 1 times 10 to the 1, let's just do a little aside here. 1 times 10 to the 1, 10 to the 1 is just 10, so this is actually going to be 10. We're going to move the decimal point. The decimal point was there. We're going to move it one place over. And in order to move it one place over, we have to put a 0 there for a placeholder. It's just math. Math is cool, right? So if we're going to go to the other direction, we have to move our decimal point one place over. So this is actually going to be 0.1 moles or molar of hydrogen ions per liter. That's my concentration. What is it times negative to the negative 14? Whoa, you ready? We have a 1, and we have to move it 14. We have to move my decimal point 14 spaces over. So we're going to have a lot of zeros to hold that place. So we're going to move 1. We move it this way, 0.1, and then that's just one movement, and then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. What? And then we have to put my decimal point there as a placeholder. Okay, ready? Which one has more hydrogen ions? Hopefully, you recognize that this number is big compared to this number, which is small. Are you good? 1 times 10 to the negative 14 has fewer hydrogen ions. That's a smaller concentration of hydrogen ions than 1 times 10 to the negative 1. So let's throw 1 times 10 to the negative 14 hydrogen ions, molarity, hydrogen ions per liter on the basic end because there aren't as many, what's the word? Hydrogen ions. And what's going to go on this end? 1 times 10 to the negative 1 moles of hydrogen ions per liter. Does that work for you? What do you think goes in the middle here? 1 times 10 to the negative 7 moles of hydrogen ions per liter. Do you follow me? Now take a deep breath. I'm going to do my pH scale in the most fantastic color imaginable on the planet, yellow. This is my pH scale. I go by my exponent. A pH of 1 is acidic. A pH of 7, a pH of 7 has fewer hydrogen ions than a pH of 1. A pH of 14 is basic. Does that totally rock your world? Okay, this is my pH. We have 2, 3, 4. These are all different concentrations of hydrogen ions and different degrees of acidity. A pH of 3 is more acidic than a pH of 5. A pH of 6 is more acidic than a pH of 7. And then we go all the way up. Now we're getting into the basic. However, a pH of 10 is more acidic than a pH of 14. And a pH of 14 is more basic than a pH of 10. Do you follow all that? A pH of 10 is less basic than a pH of 14. And all we're doing is measuring hydrogen ions. And why do we care? Because hydrogen ions change the shapes of proteins. Proteins are how you function. We're going to come back to that concept over and over and over and over again. Oh my gosh, the chemistry lecture has now been completed, and I hope you are still breathing, and go ahead and have a donut or two on me. I mean for me, because I'm not buying you donuts. All right. Peace.